Today we're going to introduce two important concepts for discrete random variables. So the learning goals for today is, after this lesson, you will be able to calculate and interpret the expected values for a discrete random variable. Calculate and interpret variance and standard deviation for a discrete random variable and recognize standard deviation as a measure of the spread of a distribution. So two concepts are expected value and variance, and regarding and related standard deviation. Actually, there's three concepts. Okay, so let's have a look at these concepts. First, let's have a look at mean or expected value of a discrete random variable. First, I'll read the definition for you and I'll give you some examples to help you understand this concept. The mean of a discrete random variable x is the value that is expected to occur per repetition on average. If an experiment is repeated a large number of times, it is denoted by mu and calculated using the following formula. That is, the expected value or mean of a random variable is the sum of the value of this random variable times the corresponding probabilities. Okay, sometimes we also denote the expected value or mean with this sign. That means the expected value of x, ex. So what does this mean? Okay, this means suppose we have a discrete random variable that can be values x1, x2, x3, etc. until xn. These are all the possible values that x can be. And also we know that x, the probability of x being each value xk is p1, p2, p3, etc. pn. And then the expected value ex. Sometimes we also denote the expected value as mu, is given by a sum of x and corresponding probabilities. So x1 plus p1, x2 plus p2, etc. plus xn times pn, which can be denoted as sigma x px. Understand? This is the definition of mean or expected value. Okay, next let's have a look at a concrete example to help you understand. In this table here, x represents the number of breakdowns for a machine during a given week, and px is the probability of the corresponding value of x. Find the mean number of breakdowns per week for this machine. Okay, so what does this mean? This means for any given week, the number of breakdowns for a machine can be 0, 1, 2, or a 3, right? So sometimes this machine is reliable, sometimes it's not. And the probability of x being 0 is 0.5, and the probability of x being 1 is 0.2. The probability of x being 2 is 0.35, and the probability of x being 3 is 0.3. Okay, and here we want to find expected value of x. That means on average, this machine breakdown, the number of breakdowns for this machine on average is how many occasions. Okay, and according to the definition, the expected value of x or the mean of x equals the sum of value times its corresponding probability, right? So it equals 0 times 0.15 plus 1 times 0.20 plus 2 times 0.35 plus 3 times 0.30, right? So this is 0. We can omit 0 here, and 1 times 0.2 is 0.2 plus 0.7 plus 0.9, which is 1.8. Okay, so what does the 1.8 mean? It means that sometimes number breakdowns is higher, sometimes it's lower, but on average for a given week, the number of breakdowns for this machine is 1.8 times. Understand? It gives you an overview about how reliable this machine is. It gives you an overview of the level of X, right? Or sometimes you can say that this is the central tendency of X. X fluctuates around this number, sometimes higher, sometimes lower, but on average, X is 1.8 times per week. Understand? Okay. Then let's have a look at another example. Find expected value of X, where X is outcome when we roll a fire die. Okay, so first of all, in order to find EX, we need to find the probability distribution of X, right? So what is the probability distribution of X? When you roll a fire die, what are the possible outcomes? Because X is outcome, right? So what are the outcomes? Outcomes can be 1, 2, 3, 4, 5, or a 6, right? So what are the corresponding probabilities? What is the probability that X being 1? Sample space has 6 outcomes, right? And in this event, we only have 1. So this is the same for X being 2. The probability of X being 2 is also 1 over 6, right? The probability of X being 3 again is also 1 over 6. And for the rest of the numbers, they all have a probability of 1 over 6, right? So what is EX? According to the definition, EX is value times the corresponding probabilities and then sum, right? So it equals 1 times 1 over 6 plus 2 times 1 over 6 plus 3 times 1 over 6 plus 4 times 1 over 6 plus 5 times 1 over 6 plus 6 times 1 over 6, right? And then because 1 over 6 is common factor, we can put it in front. And what's left behind is 1 plus 2 plus 3 until 6, right? So this is final result is 1 plus 6 over 2, which is 3.5, right? So what does 3.5 mean? That means if you roll a fire die, sometimes you get a higher number, sometimes you get a lower number, but on average, you will get a 3.5, right? Okay, do you have any questions? No? Okay, and I'll leave the rest of the question for you to solve by yourself. A stack of cards contains 1 card labeled with 1, 2 cards labeled with 2, 3 cards labeled with 3, and 4 cards labeled with 4. If the stack is shuffled and a card is drawn, what is the expected value of the card drawn? So for example, if we let X denote the number of the card drawn. We want to find EX, right? Here we want to find EX. But first of all, in order to find EX, usually we'll need to find its probability distribution, right? So I'll give you a hint. Hint is you need to find the probability distribution of X first. Okay, I'll leave 5 minutes for you to solve it by yourself. Okay, as I said, you need to find the probability distribution of X. What are the possible values and what are the corresponding probabilities? All right, let's see an example here. Let x denote a random variable that takes on any of the values -1, 0, and 1 with respective probabilities. The probability of x being -1 is 0.2. X being 0 is 0.5. Probability of x being 1 is 0.3. Okay, so the probability distribution table is x being -1 with a probability 0.2 and x being 0 with probability of 0.5, x being 1 with probability of 0.3, right? And here we want to find expected value of x squared. So what are the possible values that x squared can be? When x is -1, x squared is 1, right? And when x is 1, the x squared is also 1. So when x is 0, x squared is 0. So that means the possible values of x squared is 1, 0, and 1. And the corresponding probabilities are 0.2, 0.5, and 0.3, right? So according to the definition, expected value of x squared is the sum of each value times its corresponding probabilities, right? So this means 1 times 0.2 plus 0.5 plus 1 times 0.3, which is 0.2 plus 0 plus 0.3, right? Final result is 0.5. This is the expected value of x squared. Okay, any questions? No? All right, let's see some important properties of expected values. First one, if a and b are constants, then we will have the following property. That means if we have a linear combination of x, ax plus b, the expected value of ax plus b equals, we can first calculate ex, then times a, then plus b, right? So how do we prove this property? I'll give you a proof, okay? Proof of the first property here. So actually we want proof an equality. Usually we'll prove left-hand side equals right-hand side, right? Okay, so let's start from the left-hand side. Left-hand side equals, how do you calculate the expected value of a random variable? Apparently, the random variable is ax plus b, right? Okay, so the only method we have learned to calculate the expected value is according to the definition, right? So the expected value of ax plus b is the sum of all values times its corresponding probabilities. So each value is ax plus b times its corresponding probabilities, which is px, right? For any x, px above 0, right? Okay, so this equals, okay, this equals apx plus b times px, right? Okay, because a and b are constants. Sorry, this should be ax. Because a and b are all constants, so we can put a in front of this sign, which left us the sum of x times px plus b times the sum of all px. Okay, so according to definition, what is the sum of x times px? This is actually ex, right? This is ex. And times a plus, so what is the sum of all px? For all px, sum is 1, right? So this equals aex times b, which is the right-hand side. So in this way, we proved that the left-hand side equals right-hand side for any random variable for any discrete random variable x. So this is one of the most important property you need to remember, right? Okay, next, for any constant a, the expected value of a is always a. What does this mean? This means for any constant number, the expected value is itself. Why? Because any constant number does not change, right? So the expected value of this number is always the number itself. Okay. Okay, the third property is if f1 and f2 are functions, then the expected value of the sum or subtraction between f1 and f2 equals, again, we can first calculate the expected value of each function first and use the result then to calculate the sum or subtraction. Okay, this is another very useful property that you can use to simplify your calculation. Okay. Okay, proof, you can have a look at this after the class if you are interested. I hope you are able to prove this property. And for the last property, we have, again, this conclusion. For example, for any random variables, x1, x2, xk, and constants c1, c2, ck, we have the following conclusion. This means that if you want to find the expected value of c1 x1 plus c2 x2 plus ... plus ck xk. This is a linear combination of all the random variables, right? You can first calculate each expected value of the x's and then times the coefficient and then calculate the sum. Okay. Okay. Again, this is a very useful property that you can use to simplify your calculation sometimes. Okay. You can either remember this or this in short. Okay. Please write them down on your notebook. Okay, have a look at this. Do you have any questions regarding the expected values or mean of a discrete random variable? No? Okay, if you don't have any questions, let's continue. Next, I'll introduce the concept of variance of a discrete random variable. Okay, first, let me read you the definition of the variance. So what is a variance? If x is a random variable with mean mu, then the variance of x, denoted by varx, is defined by varx equals the expected values of the squared difference between x and its mean. Okay, so what does this mean? This means actually the variance measures the level of spread of the random variable. Suppose this is the mean of the random variable, right? The random variable usually fluctuates around the mu, right? And the variance is a measure of the level of the spread or the level of the fluctuation. So in order to measure this fluctuation, the variance is actually an expected value, right? An expected value of what? An expected value of the difference between x. Suppose this is x. This is a number from many numbers, right? And this is actually the difference between x and its mean, right? because x can be many different numbers, so this difference is also a random variable, right? So for this random variable, we can also calculate its expected values. And this expected values is naturally the measurement of the level of fluctuation, right? Okay, so because sometimes x is less than mu, sometimes it's greater than mu. In order to make it make it make sense, we put it we make it squared. So if it's squared, it's always a positive, or it's always a non-negative number, right? So for a non-negative number, this actually measures the distance between any x against its mean, right? And then we calculate its expected value. So this expected value is naturally a measurement of the level of spread. Okay, so remember this definition. Write this down on your notebook, okay? This is the definition of variance of a discrete random variable. Okay, have you done that? Again, actually we have an alternative formula for VARX. This is called alternative formula. Usually in practice, we'll use this formula to calculate variance of x. So what does this mean? The variance of x can be calculated with a difference between the expected value of x squared minus the expected value of x then squared, okay? And now the question is, how do we prove this is a property? How do you prove this? Okay, I'll show you how to prove this. Okay, again, we can start from left-hand side. Left-hand side is actually VARX, right? So how do we calculate variance? Before this alternative formula, we only have one way to calculate the variance of x, right? That is according to the definition. According to the definition, VARX is actually an expected value of the difference between x and mu squared, right? Okay, so according to the definition of expected value, how do we calculate the expected value? Expected value is actually a sum of all possible values times its corresponding probabilities, right? So what are the all possible values that x can be? All possible values is, of course, we put each x in this formula and find its difference with the mean and square. And don't forget, you need to time this value with its corresponding probability, which is px, right? This is according to the definition of expected values. Okay, then we can expand the later part, which is x squared minus 2 mu x plus mu squared times px, right? Okay, because px is common factor, so we can also put px in the square, which means x squared times px minus 2 mu x px plus mu squared px, right? And then we find the sum of the three parts respectively. This means sum of x squared px minus sum of 2 mu x px plus the sum of mu squared px, right? Okay, so what is the first part? X squared is a value, right? For each value of x squared times its corresponding probability and then sum. According to the definition, this is actually the expected value of the variable x squared, right? How about the second part? Second part, remember that mu is actually a number, right? Mu is the expected value of x, so it's a number. So we can put this number in front, and what's left behind is x times px. Plus, again, when mu is a number, mu square is also a number. So let's put it in front. So the last part is mu square times the sum of all px. Okay, so let's keep the first part. And what is the second part? Second part, according to the definition, this is a sum of each value of x times its corresponding probability. This is actually ex, right? 2 mu times ex. Ex is actually mu, right? Or mu is actually ex. These two parts are the same. Plus mu squared times, what is the sum of all px? The sum of all px always equal 1, right? Okay, first part, copy that. Second part is actually 2 times mu is actually ex, right? Ex times ex is actually ex to the square, plus mu square. Mu is actually ex, right? Ex squared. So this equals ex, expected value of x squared minus expected value of x to the second order, right? Which is the right-hand side. So in this way, we proved that this is actually a property for any discrete random variable, right? And in practice, this formula is used more often than the definition method. Okay, so please write this down on your notebook, and we'll use it to solve some concrete examples in the following of the class. Okay, please write this down, and let's see some examples. Okay, let's see an example. Calculate Varx if x represents the outcome when a fire die is rolled. Okay, remember that we can try using the second, which is alternative method, right? In the alternative formula, Varx is defined as the expected value of x squared minus the expected value of x and then squared, right? So that means we need to find the expected value of x squared. Then we need to find the expected value of x and then squared, right? So first of all, let's find the expected value of x first. So if we roll a fire die once, what are the possible values that x can be? Of course, x can be 1, 2, 3, 4, 5, 6, right? And what are the possible corresponding probabilities of x being each value? Of course, for each value, the probabilities are the same, which is 1, 6, right? Because you have a standard die. Okay, so remember that we also need to calculate the expected value of x squared, right? So we also need to find all the possible values that x squared can be, which are 1, 4, 9, 16, 25, and 36, with corresponding probabilities of 1, 6 each, right? Okay, so now first we can calculate expected value of x, which is 1 times 1 over 6 plus 2 times 1 over 6 plus 3 times 1 over 6 plus 4 times 1 over 6 plus 5 times 1 over 6 plus 6 times 1 over 6, which is 1 over 6 times 1 plus 2 plus 3 plus 4 plus 5 plus 6, right? And we have already calculated this actually, which is 7/2, right? Okay, next we also need just the expected value of x squared. So according to the definition, this is sum of value times its corresponding probabilities, right? So the possible values are 1, 4, 9, 16, 25, and 36. And corresponding probabilities are all 1/6, right? So we can use 1 times 1/6 plus 4 times 1/6 plus 9 times 1/6 plus 10 times 1/6. 16 plus 16 times 1/6. Then 25 times 1/6 plus 36 times 1/6, which is 1/6 times 1 plus 4 plus 9 plus 16 plus 25 plus 36, right? And after calculation, this number is actually 91/6. Okay, so here we have the value of EX and EX squared, right? And let's put these two values in this formula here. Okay, so VARX here is first is expected value of x squared, which is 91/6, right? Second term is EX, which is 7/2, and then squared, right? So this is actually 91/6 minus 49/4, which gives us 35/12. So this is the final result. Okay, do you understand? Any questions you want to ask? No? Okay, then let's have a look at some properties of variance. Okay, there are two important properties that I need you to remember. First, if x is a random variable, a and b are constants. For any linear combination of x, ax plus b, the variance of ax plus b can be rewritten as a squared times the variance of x. I'm not gonna prove this for you. If you're interested, you can try to prove this property after this class, okay? So please write this down, as sometimes this can simplify your calculation. The second property is for any given constant, the variance is 0. Why? Because for any constant, there is no dispersion, right? For any constant, it can only be this number. It can always be this number. So remember that variance measures dispersion, right? If there is no dispersion, that means the variance should be 0, right? So also remember this on your notebook. For any constant, variance is always 0. Okay, please write these two properties down onto your notebook. Okay, any questions? No? Okay, let's see the last concept for today, which is called standard deviation of discrete random variable. Okay, standard deviation is actually the positive square root of the variance. So by definition, this is not difficult to understand, right? Standard deviation of x is the positive square root of VARX, which is denoted as sigma. So sometimes VARX is written as sigma squared. Understand? The reason why we introduce standard deviation is that to convert the unit to something squared to the unit in the original settings, right? Again, because standard deviation is the square root of VARX, standard deviation is also a measurement of the dispersion. Understand? Just like the variance, standard deviation is also a measurement of the dispersion of X. Okay. All right. So now let's see a concrete example of the standard deviation. Bayes Electronics manufactures computer parts that are supplied to many computer companies, despite the fact that 2 quality control inspectors at this company checks every part for defects before it is shipped to another company. A few defective parts do pass through these inspections and they're undetected. Let X denote the number of defective computer parts in a shipment of 400. So note that the meaning of X is the number of defective computer parts in a shipment of 400. The following table gives the probability distribution of X. So X can be the value of 0, 1, 2, 3, 4, 5 with corresponding probabilities 0.02, 0.20, 0.30, 0.30, 0.10, 0.08. Compute the standard deviation of X. Okay, so here we want to compute the standard deviation of X. So what is the standard deviation of X? Sometimes it is denoted by mu, right? According to the definition, it's a square root of VARX, right? So first of all, we need to calculate VARX. VARX is actually the variance of X, right? How do we calculate variance of X? Usually we'll use the derived formula, right? Which is the expected value of X squared minus first calculate the expected value of X, then square, right? Okay, so this problem is converted to, we need to find 2 expected values, right? First, we need to calculate EX, and then we need to calculate the expected value of X squared, right? So let's complete this table by adding a row called X squared. Well, X being these values, the values that X squared can be are 0, 1, 4, 9, 16, and 25, right? Okay, so now first let's calculate EX. Expected value of EX, according to the definition, is the sum of value times its corresponding probability, right? So 0 times 0.02 plus 1 times 0.20 plus 2 times 0.30 plus 3 times 0.30 times, plus 4 times 0.10 plus 5 times 0.08, right? So what is the number here? The number here is 2.5. Okay, and then we need to calculate the expected value of X squared, which is, according to the definition, values times its corresponding probabilities and then sum. Okay, so let's start from X squared being 0. 0 times 0.02 plus 1 times 0.20 plus 4 times 0.30 plus 9 times 0.30 plus 16 times 0.10 plus 25 times 0.08, right? Again, we can calculate the sum. which is 7.7. Okay. Okay, and then we can put these two values into the formula to calculate VARX. So VARX is 7.7 minus 2.5 squared, right? Which is 1.45. Okay. Okay, and then we can calculate the standard deviation sigma. Sigma is actually square root of VARX, which is the square root of 1.45, which is approximately 1.204 parts, right? So that means the standard deviation of the discrete random variable x is 1.204 unit is parts. Okay, have a look at this question. Do you have any questions to ask? No? Okay, so following the same method, next example is all yours. Okay, I'll leave this example for you to solve by yourself. Okay. All right, you have 5 minutes to solve this question. All right, have you finished? Okay, let's have a look at the first one. Let X be the profit earned per annum from this product by the company. Write the probability distribution of X. Okay, so first of all, you can use a table to illustrate the probability distribution, right? So what are the values that X can be? First of all, what is the meaning of X? X is the profits earned per annum. According to the information given, that the values of X can be is 1.2 million, right? And lose 2.3, that means the profit is minus 2.3, right? And also it can be here 4.5, right? So the all possible values that X can be is 4.5, 1.2, and minus 2.3. Okay, pay attention to the 2.3. It says here it will lose 2.3 millions. So that means your profit, when you lose, your profit will be minus this number, right? So we have all the possible values of X can be, and what are the corresponding probabilities? The probabilities are given here, right? Which are 0.32, 0.51, and 0.17. These are the corresponding probabilities. So the first question has been completed. Next, calculate the mean and standard deviation of X. Okay, what is the mean? Mean is EX, which is calculated according to the definition is the sum of each value times its corresponding probabilities, right? So this is 4.5 times 0.32 plus 1.2 times 0.51 plus minus 2.3 times 0.17, right? And this number, according to our calculation, should be 1.661. This is the mean, right? How about the standard deviation? Standard deviation of X is the square root, positive square root of variance of X, right? And variance of X is calculated according to the alternative formula, which is the expected value of X squared subtracted by calculate the expected value of X first and then square this value, right? Okay, so we already have the expected value of X. Next, we need to calculate the expected value of X squared. So let's add another row denoting all possible values that X squared can be. So first of all is when X is 4.5, X squared is 4.5 squared, right? When X is 1.2, X squared is 1.2 squared. And when X is minus 2.3, X squared is 2.3 squared, right? Okay, so EX squared is 4.5 squared times 0.32 plus 1.2 squared times 0.51 plus 2.3 squared times 0.17, right? And this value is approximately 8.1137. Okay, so we need to put these values into the formula to calculate the VARX. So VARX is 8.1137 minus 1.661 squared, which is approximately, okay, let's calculate this number. This is approximately 5.3548, right? Okay, now finally we can calculate the standard deviation of x, which is a positive square root of VARx. And when we plug this value in this formula, the standard deviation of x is approximately 2.314 million. Okay, have a look at this. Do you have any questions? No? No questions? Okay, let's see a last example. Okay. Let X denote the profit you can make from a certain investment. Okay, which investment do you prefer and why? Suppose we have the following two investment options. Investment one, if we denote X as a profit you can make, that means you have a 50% chance to lose 100 and 1/8% 1/8 probability of winning 100 and 3/8 probability of profit 300. In investment two, you have 1/3 probability of losing $160 and 1/3 probability of winning $100 and another 1/3 probability of profiting 300. So considering these two investment options, which one do you prefer and why? Okay, I'll give you a hint. So usually to decide which one do you prefer, first we will have a look at of the average profit, right? So how do you calculate the average profit? We can use expected values. This is actually the meaning of expected value, right? Also, we need to consider the risk. What is the risk? Risk means your profit is a random variable that fluctuates around the mu, right? The risk is actually the level of fluctuation, which can be measured with standard deviation or variance, okay? You can calculate VAR or standard deviation to measure the risk. So in investment, usually we want higher average profit and lower risk, right? So which one do you prefer? You need to compare their expected values and risk. Okay, I'll give you 5 minutes to think about this. Okay, so any ideas? All right, according to our analysis, first of all, we need to determine which option has a higher average profit, right? So let's calculate the expected value of X in the first option first. The expected value of X is, according to the definition, it's 100 times 1/2 plus 100 times 1/8 plus 300 over, sorry, not over. Okay, plus 300 times 3/8, right? Which means 1/8 times minus 400 plus 100 plus 900. Okay, which is 75, right? And also let's calculate VARX. So remember that VARX can be calculated as expected value of X squared minus expected value of X, and then squared, right? Here we have already calculated EX, and let's put another row denoting X squared. When X is 100, X squared is actually 10 to the fourth, right? When X is 100, also X squared is 10 to the fourth. When X is 300, X squared is 9 times 10 to the fourth, right? Okay, then the expected value of X squared is okay, which is, if we put 1/8 in front, we will have okay, and final result is 40,000, right? Okay, so our VARX is 4,000 minus 75 squared, which is 34375. Okay, so the expected values is 75 and VARX is 34375. Okay, so that means we have a general sense about average profit and the risk, right? Because usually we'll calculate standard deviation and use the standard deviation as a measurement of the risk. So standard deviation of X is square root of 34375, which is approximately 185.40. Okay. All right, and then let's calculate for the second investment. For the second investment, first we need to calculate expected value of X, which is minus 160 times 1/3 plus 100 times 1/3 plus 300 times 1/3, right? And this is 1/3 times minus 160 plus 100 plus 300, which is 80, right? So unit is dollars. And again, let's calculate the variance of X and standard deviation of X. So first of all, let's calculate expected value of X squared and put another row denoting X squared. So this is 160 squared, 100 squared, and 300 squared. So the expected value of X squared is 160 squared times 1/3 plus 100 squared times 1/3 plus 300 squared times 1/3, which is 1/3 times the sum of these numbers. Okay, and final result is around 41867. Okay, so VARX in the second option is 41867 minus 80 squared, which is around 35467. Okay, so standard deviation of x is positive square root of 35467, which is approximately $188.33. Okay, so then we can compare which is preferred, right? So if you are a person that want to take risk and gain some more profit, apparently you will pick option 2, right? Because option 2 compared to option 1 has more profit with a slightly higher risk, right? But if you are a conservative person, probably you want to take option 1, which means a slightly lower profit, but also with a lower risk, right? Okay, so basically this is what we can make decisions based on the information we have. So next time when you make any decision, so first of all, you need to collect all the related information, and these informations, this data will help you to make better decisions, okay? All right, so suppose we have another option, which is called investment 3, and compared to investment 2, which one do you prefer? Okay, I'll copy the calculated values here. So we have calculated for investment 2, right? The expected value of x is $80. And we also know that the standard deviation of x is $188.33. And suppose we have another investment option, which is investment 3, with x being -10, 80, and 170. Corresponding probabilities are 1/3, 1/3, and 1/3. So if you compare these two options, which one do you prefer? Okay, I'll give you 5 minutes to think about this. All right, have you finished? So what about investment 3? So according to our analysis, you need to calculate expected value of X, right? Which denotes average profit you can make. And also it's better for us to calculate the standard deviation, which denotes the risk, right? Okay, so first of all, what is EX in the option 3? According to the definition, EX, the sum of all possible values times its corresponding probabilities. So this is minus 10 times 1/3 plus 80 times 1/3 plus 170 times 1/3, right? And we can put the common factor 1/3 in front, and what's left in the brackets are minus 10, 80 plus 170, right? Which is 80, right? So that means for the average profit, investment 3 is the same with investment 2, right? Okay, next let's calculate the standard deviation. So first of all, let's calculate EX squared in the option 3. Again, let's put another line, another row called X squared. When X is minus 10, X squared is 100. When X is 80, X squared is 6400. When X is 180 or 170, X squared is 28900, right? So the expected value of X squared is 100 times 1/3 plus 6400 times 1/3 plus 28900 times 1/3, right? And again, we can put 1/3 in front. Let's calculate what's left in the brackets. This is 35400, right? Okay, so this is squared, the expected value of X squared. Okay, then we can calculate VARX, which is the variance of X, right? Variance of X is EX squared subtracted by expected value of X, then squared, which is 11800 minus 6400, right? Which is $5400 squared, right? Okay, then we can calculate the standard deviation of X, which is square root VARX, which is approximately $73.48, right? Okay, then we can calculate these numbers. First of all, the average profit of investment 3 and investment 2 is almost the same, right? Which are all $80. But the standard deviation in option 3 is much lower than investment 2, right? So that means when the average profit is the same, the risk in the option 3 is much lower than the option 2, right? So which one do you prefer? As a rational person, I think investment 3 is more preferred, right? Because the average profit is the same, but in option 3, you will have much lower risk. So option 3 is more preferred if you are a rational person, right? Okay, so do you have any questions regarding today's lesson? If you don't, please start doing your homework for today and remember to submit it onto Google Classroom before the deadline, okay?